So over here, the question is a bit long, but let's read it together. The diagram below shows an object A of mass 8 kilograms and object B of mass 5 kilograms. Both objects are attached to the ends of a light extensible string that passes over a smooth pulley. Object C is fixed to the ground and D is a fixed plane at an inclination of 30 degrees as shown. All objects are at rest and all surface areas are smooth. G is 10 meters per second squared, so they are given the gravities, right? The basis vectors are shown below, so this is the positive, so it's indicating which directions are positive. So going towards the right is positive and going upwards is positive. Let N1 be the normal force of object C acting on object A, so we'll have an N1 over here, N1. And then and N2 be the normal force of the inclined plane acting on object B. So this will be our N2, right? Perpendicular. Let T1 and T2 be the tension force in the string applied to objects A and objects B respectively. So again, tension 1 will be this way because A would be in a way falling down, and tension 2 will be going this way, right? Given that T1 is equal to T, right? The magnitude of tension 1 is T newtons and N2 is N on 2, root 3 on 2N. Express T2 in terms of T in column vector form. Okay, so first part, T2. Right, we know that T1 is magnitude of T, right? So technically, T1 needs to be equal to T2. Magnitude of T1 will be equal to T2. And they both will equal to T. We all agree, right? So T2 over here, technically, the magnitude is T also over here. Now, we're going to resolve this into its X and Y components because we need to express it in column vector forms. So what I have is T, and we have this inclined angle, and we know that it is 30 degrees, right? So I get 30 degrees, right? It's 30 degrees over here. Two parts, so T2 will be equal to the vertical part, X on the top, right? X and Y. What will be my X part? This will be T cos 30 degrees, and this will be my T sine 30 degrees, right? So which means, however, now please notice that although this is T cos 30, again, look at which part is your positive directions, right? Positive directions towards the right. So over here towards the left, it should be negative. So writing my X, negative T cos 30 degrees and T sine 30, it is upwards. Upward is positive. Leave it like this. And then, not yet, simplify, always simplify. So what I get is cos 30 will be root 3 on 2. Negative root 3 on 2t. Sine 30 is exact angle, so half t. Okay, so this is my T2 in column vector form, okay? So far, do we all understand? Yes, okay. Now, for the second part, it says by setting up vector equations, find the value of t and n. What we can set up is our, just by looking at B, object B. So I have my object B kind of slanted, right? I have a force pulling it this way, and I have a force, normal force acting this way, right? T2, and I also have my mg, right? Force of gravity of my B, part B going down, right? And we do also know that, let me find it, all objects are at rest, okay? So this means all the forces that's acting on my object B will cancel out. In this case, I can do my adding, right? So T2 plus N2, yeah. T2 plus N2, and then plus my force of gravity of 2, right? Or if you want B, will be equal to 0. So looking at my tension 2, which I just figured out, I know that negative root 3 on 2t. and half t plus my n2. I think it is given over here. Yep. N2 will be equal to, well, I need to remember, n on 2 and root 3 on 2. Okay, n on 2 and root 3 on 2n. Okay, plus my force of gravity. There's no x, right? Because our block of B is just going straight down, right? That's just our force of gravity. What I get is negative. Also remember the direction, right? So I get negative 10, right? The question said 10 is what we can assume. And then our mass, look up for the mass, mg, which is B is 5 kilograms. Over here, we get 5 equals to 0. Right, so let's equate the top part, right? So for x, I know that negative root 3 on 2t plus n on 2 equals to 0. Second part, what I get is half t plus root 3 on 2t. Oh, sorry, root 3 on 2n. Oh, here we go. N is equal to, not yet. We have the third component, minus 50 is equal to 0, right? So equation 1 and equation 2, and guess what you need to do? Simultaneous equation, right? Solve it simultaneously. So I get n on 2 is equal to root 3 on 2t, then simply n equals to root 3t. Right, equation 3, sub equation 3 into equation 2. What I get is half t plus root 3 on 2, root 3t, minus 50 is equal to 0. So I get half t plus 3 on 2t is equal to 50, right? I move the 50 onto the right-hand side. Then I get 2t is equal to 50, and t is equal to 25. So now I found my t. Let's sub t back, right? Sub t equals to 25 into 3. What I get is n is equal to 25 root 3, okay? Here, I found my t, and I found my n, okay? Part 3, hence find the components of n1. So now it's asking for n1, and how do we equate n1? We'll be using the fact that, again, it is stationary, okay? So I know that n1 plus t1, and then plus mg of a will be equal to 0, right? Again, all objects are at rest. That's what I can use. So I know that n1 is equal to negative t1 minus mga, right? I know that t tension 1 is working in the positive axis, so, and there's no horizontal movement, so what I get is 0, and my t minus my mg, right? Mass times gravity, right? So what I get is 0. Gravity is there in the negative direction, and object A is 8 kilograms. So I get 8 negative 8 times 10. Okay. So I get n1 is equal to, right? We already found t in the previous stage. So t was equal to 25. Yep. So I get 25 minus 0, negative 80. So I get 0, right? Positive, negative 0 doesn't matter. But bottom, minus 25. Minus is 80. I get plus 0, 80. Okay. So what I get is my n1 will equal to 0, 65.